This will help us review for our Fantastic Five test for number 61 through 70. And Reed's going to help us out with our first question. What type of graph would you use to show favorite fast food restaurants? A bar graph? He said a bar graph. That would be the best way to show any type of favorite that we're dealing with. For 62, we have this number 4 circled. What type of metric unit or metric measure would you use to measure the area of your math book? We had some confusion about what the metric system was and what the customary system was, and we decided that the metric system included the base of the meter. So Riley said, centimeters? He said centimeters would be a good measurement for your math book, and it would be centimeters squared since we're dealing with length times width. And Jillian added on that we could even use millimeters. Millimeters, which are smaller. A millimeter squared would be smaller, but those would be appropriate answers. Either of those are appropriate for the test. So good to both of you. And our next one, will the following net form a cube? Yes or no? Ready? 1, 2, 3. No! Somebody raise your hand and tell me what is missing. Cedric? You have to pick one of the cubes and put it on. Good. One of the 6 cubes is placed in the wrong position. It needs to be facing a side. So it would have to be down, facing a side somewhere. Yes? And you would have to have one more side. 1, 2, 3, 4, 5, 6. How many sides do we need? 7. 2. How many sides does the cube need? 6 sides, but one of our sides also needs to be moved. It doesn't matter where it's moved from or where it's moved to, as long as it's on the other side of our figure. So it folds up and closes on the other side, the open side of the figure. On number 64, we have number 2. And can anybody remind me what this means? X over 3. X over 3. It's a fraction, but what's it telling us to do? Always. We're all fractions telling us to do. Carter, what do you think? Times 3. Times 3? Okay, so if you think these two statements are equal? No, those are not equal. Those are kind of like opposites. What else do we think? Zach? Divided by 3. Divided by 3. So let's plug in our x's for the examples in our chart. 0 divided by 3 is? 0. 9 divided by 3 is? 3. 15 divided by 3 is? 5. 21 divided by 3 is? 7. You got it, guys. And our chart up here, this was a little bit more difficult. How can we find 1/5 as a decimal? What does my base need to be in my fraction before I can put it in a decimal place? What does my base need to be? Minnie said whenever we are working with our fractions, we have to have a base of 10, 100, or 1,000. 10, 100, or 1,000. Can we easily change this fraction into a base of 10? Yes. What do I need to multiply by? 2. Times 2. On the top, we'll multiply by the same thing, and our numerator will be? 2. 2. 2/10 is our fraction for this that we can use to help us change it into a decimal and then into a percent. So what is our decimal? Everybody read it together? 0.2. 0.2 or 200. 2 what? 20. 2 what? 10. Okay, and I'm not working with tenths when I'm working with percents. What am I working with? What's my base with percent? What's my whole with a percent? Jackson? 20%. Okay, my whole is 20% because what is my whole of any percent? What is my base of any percent? Not 10, 100. It's 100. This is in the base of 100. So this, if we move right down to our 60%, is 60 over 100. What type of fraction is that? Fat fraction. It's a fat fraction. What's hiding in both of these numerators and denominators? 10. A 10. A 10. I can divide it out just by doing that. Because once I divide it out, it'll look like that. And 6/10, I can write it as my decimal now, right? 0.6. And I can write 6/10 as a fraction, but this is still an ugly fraction. by 2. And when I divide this fraction by 2, what am I left with, everybody?
3/5.
1/5. 1/5. I don't know where we got these, but 2 divided by 2 equals 1. 10 divided by 2 equals 5. So what? Okay. Whoop. I started back on the front. I don't know what I was doing. Sorry. You're so smarter than I am. Okay, and this is not the right way to write that either, so let's come down here and write 6 divided by 2 and 10 divided by 2. And Jack, what is our new fraction?
3/5.
Thank you for moving ahead even though I wasn't on the right track. And getting 3/5, which is correct. If you notice the relationship between our decimals in this column, 2/10 and 6/10, and if you'll notice the relationship between the fractions here, 1/5, 3/5. What fraction will be in between these two fractions? Right here? 2/5. Very good. What decimal would be in between these two decimals? 3?
0.4.
4/10. Y'all are good. You're seeing the relationship and patterns in numbers. That's good. For our number 66, we have the last question. Everybody, what do you think? Well, not everybody, because we might not all know. What would be the best use, or a bar graph best shows what? In general, what? Best shows what? Eli?
Observations?
No, not observations. Broader category. Cedric? A survey result. So what are we doing when we get survey results? Yeah. Very good. We're comparing, or we are comparisons or categories of whatever. We're putting them into classes or categories, or comparing the two, or the 4, or the 5, or whatever it is. That's the best use of that one. For the area of this figure, we have to break this in half, and we have to find the area of 2 different figures. How do we find the area, everybody? Just like the times width. And if we find the area of this figure right here, what is our length?
6.
And what is our width?
4.
And so our area is
24.
24 inches
Square.
Cool. Okay, this one we don't know just this portion of our length. So how could I figure that portion out right there? How can I figure that portion out? Period?
Because it would be the same as the bottom one.
No, it wouldn't necessarily be the same as the bottom one. There's another tool I need to be able to use here. What do you think that is, Kaden?
Half of 8 is 4.
Good. Half of 8 is 4. And also there's a 4 over here that's taken out that we can see. So that 4, if you take that out of this portion, you're left with 4. And so our new area of this rectangle is, or this square is? 16 inches squared. Very good. So altogether, what is my area? Well, we have to do a little addition, and these two should be an automatic fact. What are they?
10.
Good. Add your 1, and we have 40 inches squared. That's the sum of both of these rectangles area, or square and rectangles area. How many faces does this following figure have? Y'all like to fill these in, and I will do it better. So if I fill in the rest of this box, how many faces does this figure have? How many faces does this figure have? How many faces does this figure have? Emma? 8. It has 8 faces. It has a front and a back. It has 2 sides. It has a top and a bottom. Do you have anything else? No? 2 sides. It's got the 2 sides. It's got this side right here. It's got this side over here. And it's got 1 in the front, 1 in the back, and then 1 in the top and 1 in the bottom. How many?
6.
6. It's got 6 sides. Very good. It's got 6 sides. 69, our last, or second to last one, if we plug in these numbers, these values into our equation, if we plug in the 6 for the S, and if we plug in the 4 for the T, what is this fraction first? Tell me what is this fraction first. Riley?
Improper fraction.
Oh, good. And what is the sum of the numerators? is the sum of the numerator? What is the sum of the numerator? Yeah.
8.
8. And what is my denominator? 4. That is an improper fraction. How can I simplify that fraction? JD.
Simplify it to 2 over 1.
2 over 1 because they share a common factor of 4. And when I divide that out, I have 2 over 1. And we know any number over 1 really means what? It really means whatever the whole is. Because it doesn't, every number is secretly sitting on top of a 1, but we don't write it because it's not necessary. The other way we can figure this out is divide our 4 into our 8. 4 goes in 8 how many whole times? 2. 2 is our quotient for that. And our last one is, how do we find the LCM for 9 and 2? Let's list out our multiples, and we know how to do the factor three-way because it's already on the web. So let's list out our first multiple of 9. What is it?
9.
What's our next?
18.
What's the next?
27.
Keep going.
36.
Okay, I'm going to pause right there, and let's go to 6. 6, the first multiple is?
6.
Next?
12.
Next?
18.
Next?
24.
You kind of pause because why?
Because 18 is 8.
Okay, 18 is in there, and 18 is the LCM, the least common multiple of these two numbers. Very good, guys. Give yourself a round of applause.